Okay, here I have a pendulum swinging back and forth. I want to know how frequently it swings. Okay, so now by frequency I mean, okay, let's watch this for a second or for a few seconds, and then let's change the length and do this. Which oscillates more frequently? Well, this one is going back and forth much faster, so it's going to oscillate more frequently. In a minute, we'll get more oscillations here than we'll get here. Okay, so we're going to think of timing this pendulum for a minute. And we can count the number of oscillations or cycles. Now, a complete oscillation or a cycle is from here to here and back. That was a complete cycle. So I'd be counting 1, 2, 3, 4, 5, 6. Alternatively, if I wanted more accuracy in my count, I could count half 1, half 2, half 3, half 4, half 5, and then I could know whether I have, I'd actually be able to count my cycles accurate to the half. Okay, if I wanted to get really tricky, I could count. Okay, I'm going to say 1, 2, 3, 4, 1, 2, 3, 5. Okay, well that doesn't work, but I could go 1, 2, 3, 1, 1, 2, 3, 2, 1, 2, 3, 3, 1, 2, 3, 4, 1, 2, 3, 5, allowing me to count quarter cycles. Okay, now we're going to count this for a minute. We don't have too much error in counting whole cycles, but half cycles are easy. Quarter cycles might be a little trickier. And we could also count half cycles by counting 1, 2, 3, 4. Okay, and then divide the number of half cycles by 2 to get the number of cycles. Well, whatever we decide to do, we can count this pendulum for a minute. And we can use that to determine how many times it oscillates in a minute, because that's obviously what we're going to get, and that would be a measure of frequency. Now, I find that students of high school age are very bad, terrible, as a group. In any group of good high school students, say 20 students, you'll only get 2 or 3 that could accurately count this thing for a minute. Okay, if there are 50 cycles in a minute, people will count anywhere from 40 to 70. Just a lack of practice in periodic counting. People with musical training who are used to counting rhythms and so forth generally do better because they have some practice. But on the whole, there's a lot of uncertainty, and I mention that not to put anybody down. I mention that simply because there's going to be uncertainty in this data that's going to be reflected in the kind of data you end up having to analyze. Okay, now, so we count the pendulum for a minute at this length, and we measure the length. And then we change the length. Maybe we go to this length and we count it for a minute. And then maybe we make it quite a bit longer and we count it for a minute. Okay, well, we do that with a number of different lengths, and we can then get a graph of frequency versus length. The length being on this axis, the frequency, which could be in cycles per second or it could be in cycles per minute. Frequency is just how many cycles you get in some fixed time interval. Okay, standard is cycles per second, but cycles per minute make more sense in some cases, and other measures make more sense in other cases. In this case, I'm thinking that cycles per minute, since that's what you're going to be counting, is more immediate. Okay, so you really should consider making yourself a pendulum and getting data on frequency versus length. If you do, you measure the length of the pendulum, and a washer makes a really good pendulum bob because the length would then just be from the center of the washer. It's from the center of mass of whatever this is, assuming this is a uniformly distributed mass, and I won't go into too much detail, but from the center, if you used a washer, it'd be from the center of the washer to the point where you're holding it. Another caveat is if you're holding it, you really do influence this phenomenon a little bit, but that makes the data interesting. It deviates a little bit from the ideal data that you would get. Okay, so in any case, we can get a graph of frequency versus length. Now we'll go on and talk about if this was the graph of your frequency versus length. Well, the question I'm going to ask is this a power function? If so, what's the y factor, and then what is the power?